Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the two prompting tricks that have survived every model upgrade. And the surprising reason both of them work.
Two tricks. Name them and then tell me what they secretly have in common.
Few shot prompting. Show. Don't tell. And chain of thought. Think before you answer. And here's the unifying idea. Both work by exploiting the autoregressive loop. The model predicts the next token from everything in its context. So if you stuff helpful tokens into that context, you bias the very next prediction in your favor. That's the whole trick for both.
Let's take few shot first. First, zero shot is just describing the task. What does few shot add?
You add 2 to 5 worked examples, and the model pattern matches and continues the pattern. Say you're converting plain English times to 24-hour format. You show it 3:15 in the afternoon becomes 15:15. 10 to 9 at night becomes 20:50. Then you ask your real one, 7:30 in the morning, and it answers 7:30, copying the pattern.
Is there a right way to feed it those examples? I've seen people just paste them all into one big blob.
And that's the dated way. The modern idiom. Both the OpenAI and Anthropic APIs is each example as its own separate user then assistant turn in the messages array. It matters because the model treats those assistant turns as authoritative demonstrations of correct behavior, and the assistant turns quietly teach format too. If your examples are terse with no prose, the model copies that terseness.
Okay, when is this genuinely worth the tokens? Because every example rides along in every request.
When the format is niche, a custom DSL, a weird date convention the model hasn't seen much. When you need domain-specific labels, like classifying tickets P0, P1, P2 by your on-call docs, for matching your brand tone, or to anchor a tricky edge case. But it's wasted on tasks the model already nails. Summarization, general Q&A. There, examples just eat your budget.
Here's a question I actually care about. If I'm going to pick examples, which ones give me the most for my money?
This is the highest ROI move in all of prompt engineering, and it's counterintuitive. The most valuable example is not the most typical input. It's the edge case you keep getting wrong. If the model insists on turning noon into midnight, you add noon becomes 12 as an example. Mine your examples straight from your eval failures. Typical inputs the model already handles teach it nothing.
Got it. Now, chain of thought. What's actually happening when I tell it to think step by step?
You're asking it to show its work before committing to an answer. And the mechanical reason it helps is precise. Each token it generates can attend to every token before it. So by writing out the intermediate steps first, the model gets to condition its final answer on its own reasoning. The steps are scratch space, and the answer reads from the scratch space.
Give me the example where that difference actually shows up.
A train leaves at 2:15 and arrives at 5:03. How long? Asked cold, the model often blurts 2 hours 45 minutes. Wrong, because the minutes aren't round. With chain of thought, it reasons 2:15 to 5:15 would be 3 hours. But we stop at 5:03. So 3 hours minus 12 minutes, 2 hours 48 minutes. The scratch work caught the error, the snap answer missed.
So when does reasoning actually pay off versus just slow me down?
It pays for multi-step math, multi-hop reasoning where you chain facts together, logical deduction, pulling answers out of many documents. It hurts on simple lookups. Capital of France needs no reasoning. You've just added latency and tokens. And it clashes with structured outputs. If you're forcing a terse schema, asking for prose reasoning fights it.
Wait, there's a tension I want to name. If both few shot and caught just nudge the next token, neither one teaches the model anything it doesn't already know. So can chain of thought ever make a wrong answer worse?
That is exactly the sharp catch. And yes, chain of thought doesn't make the model correct. It makes the answer sound more confident. If the model's heading somewhere wrong, the reasoning can just be an elaborate rationalization of that wrong answer. Now dressed up to look rigorous. Neither tool adds knowledge. They shape the response. They don't fill a gap in what the model actually knows.
And there's a newer option, right? Models that reason on their own?
Right? And the rule there is clean. Reasoning models. The O series are one style, Claude with extended thinking. Already do the chain of thought internally before you see a word. You don't tell them think step by step. They already are. And manually adding it can actually interfere. They cost more and run slower, tuned by a thinking budget. So the rule of thumb, if the task is hard for a human, real math, code, multi-step planning, reach for a reasoning model. For everything else, a standard model with a well-built prompt is faster and cheaper.
So the takeaway in one line.
Few shot shows the model the pattern. Chain of thought gives it room to work. But both only steer what's already in there. They shape the answer. They never add the knowledge.
Show, don't tell. And think before you answer. That's the Datarekha audio guide. Catch you in the next one.